So we're going to do these problems. I'm going to show you them as examples. You could, if you want to, you could maybe kind of like try it yourself first, because we have gone over this in class and you've practiced it. If you want to use it, like, do that and then watch and make sure you got it right, you could do that. I would recommend. But just a few more examples, because we didn't get a chance to do a lot of them in class. So a football team plays in a large stadium with a ticket price of $20. The average attendance has been 30,000 people. All right, so that's your piece here. A survey indicates that for each dollar increase in ticket price, so every time you increase the tickets $1, so like say 21, the attendance decreases by 500. So this will go down to 29,500. Okay, and then, so keep it up. So 22 would be 29,000. 23 would be 28,500. 24 would be 28,000. So we want to kind of come up with a scenario here, like an equation of what's happening for the number of spectators, right? That's going to be our formula for n of x. Like, what's the number of spectators? Well, the number of spectators depends on the x value, the price. So we were starting at 30,000, so we'll put that. We're taking off 500 for every amount or every dollar over 20. So what we want here is we want to take whatever we're going to charge minus 20. That'll get us the amount over 20. So let's try it. So let's put in like 24. 24 minus 20 is 4. 4 times 500 is 2,000. And 30,000 minus 2,000 is 28,000. Okay. All right. So our n of x is 30,000 minus 500 times x minus 20. Okay, so let's clean that up a little bit because we're going to use it later on. So let's see, that's 30,000, 500 times x, and then minus times a minus would be a plus, and that's going to be 5 times 2 is 10 with 3 zeros, so 10,000. So my n of x has now changed into 40,000 minus 500x. So it kind of doesn't make sense anymore to us, but like I saw it came from this, which did make sense. Okay, so express the revenue from a football game. So remember, your revenue is going to be however much you charge for tickets times how many people buy tickets, right? So it's like x times n of x. So that's like the logical thing that it is. So we're going to take x and multiply it by what we got here. So 40,000 minus 500x. Okay, so that's basically it. I could put that in Desmos or my calculator or whatever, but I'm going to go ahead and clean it up. So x times 40,000 is 40,000x, and x times here would be negative 500x squared. So to put it in standard form, I have negative 500x squared plus 40,000x, right? Okay, so let's go ahead and put that in our calculator here, or in Desmos actually. So let's see, Desmos, here we go. So y equals, I got negative 500x squared, plus 40,000x. Okay, all right, so I'm gonna do this graph. Remember, my x value is here, right? Oh, I'm sorry, my x value is on the bottom axis. So let me zoom out a little bit. Let me drag this over and zoom out so I can see what it is. All right, that's good. I see it's touching at 80 over here. So let me adjust my height because I need to be a lot higher than this. So I don't know, it's a really big number probably. I mean, if you think about, 20 times 30,000, that's going to be 60,000, no, 600,000 or something. So let's put in a really big number. So let me put in like 100,000. All right, so I'm starting to see some curvature. So good. So why don't I put in 200,000? All right, 300,000. Let me put 400,000. All right, let me put 800,000. All right, that's good. Let me just put a 9. All right, so 900,000. That's what I'm starting to see there. All right, so it's a good picture. And now I'm going to want to kind of label my sides. All right, my x value is my ticket price. So my ticket price, and that is in dollars. Okay, And then my Y value is my revenue. So it's the amount of money that I bring in dollars. It's not my profit necessarily, but it's what what I'm bringing in from the ticket sales. All right, so you see I have that there on my screen. All right, so let's go put this on our paper. So we're gonna draw this. We're gonna have this point. We're gonna have this guy over here as well. Okay, so we'll draw that on our paper. We will put the point 40 and 800,000 at the top. On the side, we'll put 80, 0. Okay. And so basically, then this is my ticket price in dollars, and my revenue in dollars. Right. And this one over here was 0, 0, but whatever. You know, you don't sell any tickets, you don't make any money, right? Okay, so determine the ticket price. That is for the maximum revenue. Well, that's this right here. The ticket price that gives the most money is $40. Okay, so put a dollar sign. What's the maximum revenue? $800,000. And one more little thing we could maybe do. How many people are attending the game if we charge $40? So let's figure it out. So if I have 30,000, so the N is the number of people attending, 30,000 minus 500 times 40 minus 20 is 20. So if you calculate that answer, so 30,000 minus 500 times 20, that is 20,000 people. So there's 20,000 people coming to the game, and that's less people, but that's okay. That's where I make my most money. Okay, so that's kind of like the sweet spot. Okay, next one. You have 800 feet of fencing to enclose a rectangular field. However, one side of the field lies along a river. So you have a river over here, right? And you're gonna like put some fence here. So basically you don't need any fencing along the river. I mean, I don't know, I guess your things that are in there aren't gonna go in the water or something like that. So draw a picture for the scenario. Label the side of the fence parallel to the river as X, and the other two sides with a Z. Right, we're going to write an equation for the perimeter of the fencing, or the amount of fencing. So basically, two Z's and an X have to add up to 800. So 2Z plus X have to add up to 800. Now, at some point in this later on, I'm going to need to solve this for Z, because all my equation is going to be in terms of X. So let's just do that now. So I'm going to just take away X, so 2Z equals 800 minus X, and then I'm going to divide by 2. So I have 800 minus X over 2. If I clean that up, I can say that it's 400 minus, this will be like 1/2 X. So it's up to you whether you want to leave it a fraction or put it like that. Doesn't matter. Okay, so let's take a look. So express the area of the field A. So remember, the area of a rectangle is like the base times the height, or the length times the width. So this rectangle, I'm going to be doing Z times X. All right, so I'll be doing, or X times Z. Now, remember, that's why we had to solve for Z on that problem. So X is X, but Z, that was my 800 minus, what was it? 800 minus X over 2. All right, so this is fine. We can just leave it like this. And we're just going to put it into Desmos, but we could also fix it up. So we could make it X times, this is 400 minus 1/2 X. So if I clean it up, that's 400X minus 1/2 X squared. So that's negative 1/2 X squared plus 400X. So I can see it's a parabola, it's upside down. This is my formula for my area. Okay. All right. So let's go ahead and go to Desmos. All right, I wonder if there's a way to like reset. Oh, what's this home screen do? All right, let's do that. All right, so let me get rid of this. I'm gonna get rid of these words. The height is gonna be the area. The Y value is the area in square feet. Let me see, was this in feet? Yes. So in square feet. And the x value is going to be basically the width or the length or the height, however you want to say it. That's in feet. Okay, so here's my equation. -1/2 x squared plus 400x. Okay, so my graph got kind of crazy. So I'm going to drag it over here, zoom out until I see my x-axis. Where is it? Oh, there it is, 800. So I need to go ahead and increase my height. So my y value, I don't know, let's make it like, let's try 1,000. Nope, not seeing anything. So why don't we try 40,000? Okay, seeing more, let's do 60. Nope, let's do 80. That's okay, let's do 90. There you go. All right. Okay, so there's my high point. Here's my x-intercept over there. Okay, so let's get this drawn on your paper. So we got 800, 0. The bottom axis is my, oops, I mixed that up, didn't I? I want my area to be my y-axis, and this is my length. And my top point is 400, 80,000. All right, so remember that 400 is my x value, so that's my length. And then the 80,000 is my maximum area, right? So, there we go. All right, what are the dimensions of the field with the maximum area? So I know x is 400. So it's going to be 400 feet by, and it's kind of small here, but I have to think back to what was going on. So what we're saying here is that this is 400. Well, I have 800 to spend. So 800 minus 400 leaves me 400 left between these two sides. So 200 each. So 400 by 200 is the best scenario. You could also get that by literally plugging 400 in for x in this problem right here. Okay. So 400 by 200. So 200 feet. So my dimensions are my x and my z. All right, maximum area. There it is, because that's what this is graphing. So 80,000 square feet. Okay. All right. So here, you have 1,200 feet of fencing to enclose this rectangular region here. It's subdivided into 3 smaller pieces. So this is x, and then we got 4 y's. Okay, so let's write an equation for this amount of fencing. So we have 2 x's plus 4 y's have to add up to 1,200. So just like before, I'm going to need an equation for y in terms of x. So I'm going to take off 2x, divide everything by 4. So I'm going to get y equals, you could write 1,200 minus 2x over 4, or you could actually divide it out and say that's 300 minus 2/4 would be 1/2 x, however you like to do it. All right, so my area is x times y. So the reason I wanted an equation for y was because there's my area, is x times y. So x times, and we're going to fill in what y is, 1,200 minus 2x over 4. But if I clean this up, it's 300 minus 1/2 x, and multiply it out, minus 1/2 x squared. So basically my area formula is negative 1/2 x squared plus 300x. All right, so let's draw this picture a little bit before we go to Desmos. It's going to go through the origin. It's going to be like this, okay? this x value right here, that's going to be like my width in feet, right? This up here is going to be my area in feet squared, okay? And we're going to use Desmos to pretty much find our values here, okay? All right, let's see. So I think I'll just leave this, and look, all I gotta do is change this to a 300. All right, and my picture, look, and the length and the area, that's all fine. You can put length or width, up to you. All right, so 345,000. And then on the right side, it's gonna be 600 and 0. Okay, so dimensions, so that's going to be my 300. Now my 300 feet, remember that's just x. So if I'm going to use 300 here and 300 there, that's 600 off, right? So I have 600 left to divide by 4. And 600 divided by 4 is 150. So by 150 feet, okay? So also what I could do is plug 300 into here, and that would give me my y value as well. Or just think of it logically. All right, and the maximum area is the 45,000 square feet. Okay, last one. So we got a volleyball served into the air at 30 feet per second. That's this number here. A height of 6, that's this number there. So we're going to do this without looking at our calculator, I'm sorry, without looking at Desmos. So I know that it's starting from 6, right? And you know, the volleyball goes across there. So it's like projectile motion, right? And crosses right here. So this is my time, and it looks like it's in seconds. All right, this is my h of t, my height of the ball, and that would be in feet. Okay. All right, so there we go. So what's the maximum height of the ball? So I'm looking for this spot right here. And I had to find that, I need to go ahead and find what time that occurred. So to find the x value, the t value of this vertex, so x, and in our case that's t, I'm going to do negative b over 2a, because that's going to be the x value of the vertex. And I'm going to take that answer and I'm going to plug it into my equation so I can find the height, the y value. So I'm going to do negative 30 over 2 times negative 16, so negative 32. So basically 30 over 32, but that reduces to 15 over 16. All right, so 15 over 16, you know, you divide it, it's 0.9375, so it's like almost 1 second, you know. So we can do 0.9375, or I can do 15 over 16, but I need to plug that into my height formula. All right, plug it in here, negative 16, 15 over 16 squared plus 30 times 15 over 16 plus 6. All right. Okay, so let's see. Negative 16. Now, you can do one of two things. You can do 15 divided by 16. I don't really care if my answer is a decimal or a fraction. You can do it like that and then square it. Or if you prefer, you can use the 0.9375. Or if you prefer, you can make a fraction and just put 15 over 16, okay? And if you do it this way, plus 30, 15 over 16, oops, dang it. It comes out as a fraction. So yes, it is 321 over 16, but that doesn't really mean a lot to us. So let's take 321 divided by 16. Oh, so you mean 20.0625 feet, right? Because that's the height of the ball, okay? So we'll just say like 20.1 feet, all right? It didn't really say to round off or anything, but that's fine. All right, if the volleyball is untouched after the serve, how long does it take before it reaches the floor? So I basically want to know this spot right here. So I want to know the x-intercept. Well, the x-intercept means I'm going to do the quadratic formula. So I'm going to do negative 30 plus or minus, we'll figure out the discriminant in a minute, over 2 times a. So 2 times negative 16 is negative 32. All right, so let's do that discriminant. So I need b squared. So 30 squared minus 4 times a is negative 16, and c is 6. All right, so 1284. Okay, so this is going to get me two answers. Let's see what they are. Fraction, 30 square root. All right, so negative 2.06. Well, that doesn't make any sense for time. So I'll do it again. This time plug in a minus there. And there we go. 0.18, we'll say. 1/8 seconds. Well, that's pretty fast, right? So 0.2 of a second it lands on the ground. All right. So pretty quick, but you get the idea. So 0.18 seconds. Okay, that's it. Bye-bye.